Hello, this is Ken Bush again with part 2 of the presentation, Composite Wood-Based Decorative Surfaces. Part 2 covers composite wood panels. This presentation is made possible by Arauco Prism. Prism is a brand of thermally fused laminate. Arauco is a producer of TFL panels as well as raw panels. Omnova Solutions, a producer of 3D laminates as well as other materials for the interior design markets. Wilson Art, a producer of high-pressure laminate, as well as thermally fused laminates. And Olan, a producer of decorative lightweight papers and foils. This presentation was created by Ken Bush of Material Intelligence. You can visit our website at materialintelligence.com, and you can email me, Ken, K-E-N-N, at materialintelligence.com. So we are talking about the laminates industry, so it helps to maybe start with exactly what it is. There is no such thing really as a laminates industry. It is really the intersection of so many other industries whose products and processes go into creating what we know as decorative laminates. Paper manufacturers, resins and additives, ink producers, printing cylinder engravers, the people who actually do the printing, the decor paper printers, saturators, those are the people who make sure that the paper is treated so that it can be converted into a laminate. Press plate and release paper manufacturers, this is where your textures come from. Equipment manufacturers, of course, laminators, the people who bring it all together. Composite panel producers, those are the guys who are creating the substrates that all these materials adhere to. Materials distributors, and of course designers. And what I am trying to do is bring designers closer into that full loop. So we, as an industry, are not just trying to create something from scratch and introduce it to the design world. We want to start with the thinking of designers and execute exactly what it is they're looking for. So composite wood-based panels have to start with wood. Wood is actually nature's perfect building material. It is so integral to human evolution. I like to say that, if it weren't for wood, we wouldn't be here. Shelter, fire, heat, everything up through musical instruments. So much of what makes us human has only been made possible by our knowledge of how to work with wood. It is really the only living building material. If you think about it, trees build themselves as they grow, and in doing so, they engineer in all these properties that are so important for structures and for furniture: mass, strength, resilience. Really, nothing has quite that combination in a lightweight building material as wood. And wood is, it's even after harvested and installed, it still continues to respond to changes in heat and moisture. So, in a way, it is it's a living material even after it's been harvested and converted into building materials. Wood is also an infinitely resilient and renewable resource. According to a study by Harvard, over 400 years of northeastern forests, despite the clearing, the logging, fires, climate change, pests, disease, and human interaction, civilization, the Northeast remains the most heavily forested region of the country. And this is also true in the Midwest, where I live. If you stop mowing your lawn, you will eventually get a forest. Hardwood growth rates in North America exceed the removal rate by 2.45 to 1. So for every one tree we're taking out, we are planting or we are encouraging the growth of 2.45 more trees. So literally we have more trees in our forests than we did 50 years ago, 100 years ago. Wood sequesters carbon. 50% of wood's chemical structure is actually carbon that it absorbs as it grows. And this is not released back into the atmosphere until it burns or decomposes. A tree can absorb up to 48 pounds of carbon dioxide per year and can sequester 1 ton of carbon dioxide by the time it reaches 40 years old. Once that tree is fully mature, however, the carbon intake does slow and nearly halts. Younger trees are more effective carbon absorption machines and oxygen producing machines than older trees. So younger forests are actually healthier for our environment. The composite wood panel industry uses up to 99% of every tree harvested. The forests are carefully managed, FSC certified, and every possible waste product from the tree is utilized in one way or another. And this is not just to be green. These industries evolved by making the most out of the natural resources and caring for their resources. You can see this picture here is a plantation. These are fast-growing softwood trees that are used for composite panels. Generally, they mature in about 25 years rather than 40 to 60 years. And like was mentioned before, they are young, healthy, very well cared for trees. Really, instead of a forest, you might think of something like this as more of a crop of carefully managed resources for the furniture and interior building industry. Basically, all the byproducts from trees have some sort of use. Tree bark can be processed into mulch and soil conditioners. Sawdust can be used to operate kilns for drying wood, also sold off for animal bedding. Trimmings are chipped and processed into paper and other products. And all of this saves millions and millions of tons of wood from landfills every year. And this is all fiber that would otherwise be burned or buried. Now, the sequestered carbon we mentioned earlier, that is sequestered until the wood is incinerated or decomposes. At that point, the carbon is released back into the atmosphere. So composite wood panels are really the ideal substrates for decorative surfaces. And this is because they are so carefully controlled for surface and dimensional stability. The smooth surface for decorative surfaces like veneers and laminates, very, very important for efficient processing and for the final look of the decorative panel, a smooth and consistent surface. These panels can also be specially engineered for moisture resistance, fire retardancy, lighter weight, higher hardware holding strength, acoustic properties, etc., etc. And they are also much more dimensionally stable than solid wood would be. And that's because the fibers in composite wood panels have been basically reoriented so there's no singular direction. In a solid piece of lumber, the fibers are all essentially heading the same direction, which means any changes in moisture and heat, those fibers, it's just going to amplify the change, and that's where you get your warping and cracking and splitting of solid wood. Composite wood panels will not warp, crack, or split, and they hold their dimensions very, very well. So, re-emphasizing the point that the reoriented wood fibers are what gives composite panels like particle board and MDF their dimensional stability, and that dimensional stability is then what makes them the perfect substrate for any kind of decorative surface, whether it is a laminate or a veneer or a lacquer or a powder-coated finish. The decorative surface goes on the top of the panel, and in many cases, whether it's a laminate or a veneer, a balancing sheet of laminate or veneer is used on the bottom of the panel to make sure that the panel stays flat. Because the surface is made from different material than the substrate itself, there can be some differences in how the surface responds to temperature and humidity changes. And if you balance the panel with the same type of material, doesn't need to be decorative, just needs to have the same properties. On the bottom of the panel or the back of the panel, it ensures additional stability. All panels produced in North America meet CARB 2 standards, the California Air Resources Board version 2 standards, which cover indoor air quality and the amount of emissions that products can have. Every panel produced in North America meets or exceeds those standards. The net carbon footprint of decorative panels made with particle board and MDF actually offsets some of the CO2 in the atmosphere. Because wood sequesters carbon as it grows, the carbon sequestered in the fibers used in particle board and MDF panels is actually more than what is expended in the energy in creating the panels. That's harvesting, processing them into panels, adding value with decorative laminates, transporting and installing. After all of those steps, panels have been found in a life cycle inventory analysis to have been to be better than carbon neutral. In other words, offsetting more carbon, sequestering more carbon than is expended in all those processes. Particle board, as the name implies, is made up of small chips, wood chips bound together by different kinds of resin systems under heat and pressure. These resin systems, essentially, they're glues. You can see in the particle board image here, the face, the top and the bottom, is a little bit denser, a little bit smoother than what you see in the core. Larger chips are usually used in the core of particle board. Finer chips in a denser mat are used on the tops and bottoms to increase the surface smoothness, which increases the bond with whatever surface you're putting on it. The less dense core of the panel saves some weight, saves some materials, and makes the panel just a little bit more easy to handle. The MDF is actually made up of wood fibers, so the particles are actually refined a little bit further down into just the wood fibers, and you can see that the panels themselves are a lot denser through the core. It's a much finer surface on the top, and as you machine into the panel, you still get a nice fine surface, and this is important for any type of decorative panel that will carry any sort of machining or details carved into the panel. That life cycle impact analysis found that particle board contains over 90% recovered fiber, MDF contains over 80% recovered fiber, and both of these panels use fiber that's left over from other woodworking or lumber mill processes. So the offall from a lumber mill, the offall from plywood plants, and even fiber that's left over from the manufacturing process. And some plants are actually able to use post-consumer wood fiber. So these materials actually start life as a recycled product. 7% of the fiber is used in general in the manufacturing process, and this means it is incinerated to heat the plant and to run the big presses that create these panels. Less than 3% is landfilled, and again, that number in most North American plants is much less than 3%. The industry itself manages to use about 99% of the harvested lumber fiber. And we can't really talk about composite panels like particle board and MDF without mentioning the F word, formaldehyde. It's been in the news, and it is an essential building block of the adhesives, the resin systems that bind these panels together. It's also a natural occurring element in wood. Trees will emit formaldehyde. As a matter of fact, every living thing emits some amount of formaldehyde. It's present in every cell in the body, and low levels are part of our everyday lives. There's a certain ambient level of formaldehyde that there's no way to escape, and it's been around forever, so there's no reason to be alarmed by the ambient levels of formaldehyde. Formaldehyde is actually an essential building block of hundreds of products. Makeups, vaccines, pill coatings are made from formaldehyde resins. And like I mentioned, so many glues, the most effective glues and resin systems are produced with formaldehyde. It is one of the most studied compounds in history, and it does not accumulate in the body. Humans actually metabolize formaldehyde quite quickly. No other compound offers the same sorts of benefits as formaldehyde-based resins. They do not break down under heat. They are resistant to fire and heat. They are pest resistant. They are manufactured safely. They have a high degree of stability once processed and manufactured, and they're very effective in binding wood fiber. The emission levels allowed by CARB Phase 2 from a particle board panel are 0.9 parts per million. In MDF, it's a little bit higher because there's actually more wood fiber in a panel, an MDF panel, 0.11 parts per million. To compare that to fruits and vegetables, which off-gas between 3 and 60 parts per million, meat and fish between 6 and 20 parts per million, human blood actually off-gases 2.5 parts per million formaldehyde. And the average daily adult intake of formaldehyde is between 1.5 and 14 milligrams, and that's mostly from food, but other ambient formaldehyde levels affect that. I do not know how to convert parts per million into milligrams. LEED credits made available when using particle board and MDF as substrates with decorative surfaces. Now, these are the old LEED measurements, which people are still very comfortable with. MR7 certified materials. North American composite wood panels come from FSC certified forests, and the entire process is FSC certified. MR 4.2 recycled content. North American composite wood panels contain a high level of recycled material. And EQ 4.4 low emitting materials. Again, these panels all meet or exceed the stringent CARB 2 emissions requirements. In 2011, at the Milan Furniture Fair, Saloni, the area they call Saloni Satellite, which is where the young designers and students are invited to show off their ideas, there was a huge particle board sculpture made by the designer Lorenzo Damiani. His goal was to demonstrate the worth of worthless materials in alternative ways with the aim of protecting resources. A quote from him: "Using resources and materials responsibly, striving to give dignity to materials normally perceived as worthless." Proposing alternative uses of existing materials. This is the challenge of today and above all tomorrow. Damiani says, "This is why I chose to use composite wood panels in a different way. In the future, the distinction between valuable and less valuable materials will disappear because they will all be valuable. So, why not get ready now?" Thanks for watching part 2. Stay tuned for part 3, where we're going to cover Y laminates and high pressure laminates. And do please visit our sponsors.